In this lecture, we are going to focus on an equation of a plane, in particular a three-dimensional plane. Well, one way we can describe a plane, one way we can visualize a plane is by what we call a normal vector. A normal vector to a plane is a vector that is perpendicular to the plane. Now, let's actually visualize that. If I have a plane here, that imagine there being a vector, in this case the black vector here, that is going to be perpendicular to this plane no matter which angle we look at it. So in this case, my black vector is going to be normal to the blue plane that we have here. And if let's say I move this black vector around, notice that my plane will keep being perpendicular to the black vector here. So we can describe a plane by, we can describe the kind of the angle of the plane by the vector that is perpendicular to it. So, in general, the equation of a plane in three dimensions is going to be ax plus by plus cc equal to d. Here, let's see, my a, my b, my c, and my d. These guys are a number, these guys are a constant, and my x, y, and z. These guys are my variable in three dimensions. So, what is particularly nice about this form of equation of a plane is that it actually tells us right away what is the normal vector of this plane. The normal vector of this plane is going to be just the value of ABC, which is the coefficient for x, for y, and for c that we see here. So, let's kind of take a look at the first example that we have down here. I'd like to find an equation of the plane. So let me kind of try to sketch that. So 3D things are a little hard to draw, but I hope you can imagine. So I'd like to find an equation of the plane that passed through 1, 2, 9. So it's kind of 1, 2, 9. And I want the plane to be perpendicular to the vector 1, negative 2, and 1. 1, negative 2, and 1. So this is going to be a little hard to draw. Let me see, how do I draw this thing? Something like this, I hope. Yeah, this looks parallel. How about something like this? Okay. Yeah, you can imagine. So I want a plane that passes through this point and is perpendicular to this vector here. Well, let me do the long way first. So let's say if I have a point x, y, z that lies on this plane. Now then, what would be the general formula for this point x, y, z here? Well, one thing that needs to happen is that I'm going to need this vector here. Because the plane is perpendicular to my red vector. So this plane here is perpendicular to my red vector. So what needs to happen is that this little vector here needs to be perpendicular to my red vector. So I'm gonna want the pink vector to be perpendicular to the red vector. It doesn't seem so in my 2D drawing, but in 3D, let's kind of say they are perpendicular. So that means I'm gonna want my pink vector. What is the coordinate of my pink vector? My pink vector, this is going to be x minus 1, y minus 2, and z minus 9. Now, I'm going to want this vector to be perpendicular to my red vector. In vector world, what does it mean for two vectors to be perpendicular? For two vectors to be perpendicular, that means I want their dot product to be equal to 0. So the dot product of this guy, the pink vector, and the red vector, this better equal to 0. So, what does this come down to? Let's see. The dot product of this guy, I multiply the first coordinate together, so that's going to be x minus 1 times 1. X minus 1 times 1 plus y minus 2 times negative 2, y minus 2 times negative 2 plus c minus 9, c minus 9 times 1. Okay, so let me simplify this thing a little bit. I'm gonna have x minus 1 minus 2y plus 4. And then let's see, plus c minus 9 equal to 0. Now let me collect the x and y and c. I'm gonna have x minus 2y and then plus c equal, let's see, 4 minus 1 minus 9. I'm gonna get negative 6. So if I move that to the right hand side, I'm gonna get a 6 here. So this is the equation of the plane that I want. This is the equation of the plane that is perpendicular to this red vector here, and it goes through 1, 2, 9. Now, notice how the coefficient of the x, y, z that we have down here, the coefficient for x is 1, the coefficient for for y is negative 2, the coefficient for c is 1. So this 1, negative 2, and 1, this is precisely the normal vector that we have to begin with. Now that we see this, let me actually show you another way to obtain this same answer. I want a plane. So I want a plane that is perpendicular to 1, 2, 9. So I knew that the general equation of a plane is ax plus by plus cc equal to 0. Not equal to 0, equal to d. And I knew that the normal vector to this plane is going to be just the value abc. In this particular case, because I knew already that the normal vector to this plane is 1, 2, 9, so I knew right away that my a is going to be 1. So it's going to be, not 1, 2, 9 here, sorry. So I mean 1, negative 2, and 1 here. So the normal vector is 1, negative 2, and 1. 1, negative 2, and 1. So that means my a is 1, my b is negative 2, and my c is 1. So here, I have already the coefficients for x, y, and z down. I only need to identify the value of this d here. How would I go about to do that? Well, I knew that this plane would pass through this point 1, 2, 9. So that means if I plug in x equal to 1, y equal to 2, and z equal to 9, the value of the d here better satisfy the equation that I have. So let's do that. If I plug in 1 for x, I'm gonna get 1. I plug in 2 for y, I get negative minus 2 times 2, and I plug in 9 for z, I get a 9. And the value of this thing, 1 minus 4 plus 9, this is equal to 6. But this has to equal to d, so that means I knew the value of d has to be 6. In particular, I have already obtained the equation for my line. This is going to be x minus 2y plus c equal to 6. So this is the equation of the line. And that's actually kind of what we have seen earlier as well. Now, well, we can actually generalize this further as well. If we were to generalize this problem, let's say if I want to find the equation of a plane that passed through the point x0, y0, c0, and I want this plane to be normal to the vector. Well, let me use this color. I want the plane to be normal to the vector ABC. The equation for this plane is going to be x minus x0, y minus y0. I need to write a vector, y minus y0, and then c minus c0. I want this to be perpendicular to ABC, so I'm going to want the dot product of this guy, A, B, C, to equal to 0. In particular, I'm going to have A times x minus x0 plus B times y minus y0 plus C times C minus C0 to equal to 0. So this in general, this is the general formula for the plane that is going through x naught, y naught, z naught, and is perpendicular to the ABC. But if you understand how to define a plane from the normal vector, then there's actually no need to memorize this formula here.